Hello, everyone. My name is Karesia Ramlal, and I am a postgraduate student at the University of the West Indies. I will be presenting on a personalized overdraft protection framework. Our presentation will be ordered as follows. First, we will examine the problems with existing overdraft protection options. Then we will highlight the key components of our proposed solution and the methods used. We will illustrate our personalized framework through a comparative study that demonstrates the benefits to both customers and financial institutions. An overdraft occurs when a customer's bank account goes into a negative balance, usually as a result of processing a transaction that exceeds the available amount. Overdraft protection is offered by some commercial banks as a means of avoiding this through a pre-approved transfer of funds up to a specified limit. Now, this sounds like a good idea until you consider the fees and interest rates attached. A 2019 report by the Center for Responsible Lending in the United States found that the average overdraft usage fee was $35 per transaction. The market research shows that customers are dissatisfied with current overdraft protection options, namely issues surrounding fees, interest rates, and authorized limits. The key components of our proposed frameworks are as follows: an overdraft risk assessment, variable interest rates and authorized limits, stratified fee structures, and a deferred repayment option. Banks already collect a large amount of data on their customers. Our solution seeks to utilize customer data to provide them with a personalized approach to overdraft protection that better suits their needs, while maintaining benefits to financial institutions. We modeled our framework using two anonymized datasets from a private financial institution. Our framework consists of the following personalized steps, which will be discussed further in the slides that follow. For the purpose of our study, we assume that overdraft protection is offered on an application basis, which allows the financial institution to better manage their risk. We express overdraft approval and overdraft default risk as two binary classification problems. We define overdraft risk as the probability of a customer defaulting on their repayment, which occurs when a customer uses up their overdraft limit but does not make any deposits to the account after, thus resulting in a loss for the financial institution. We consider two tree-based algorithms, Random Forest and XGBoost, for the task of modeling customer overdraft approval and default risk. We also tested a logistic regression model and found that both Random Forest and XGBoost had a better overall performance for the given dataset. After predicting a customer's overdraft application approval and their risk of default, we performed time series modeling on their average monthly expenditure to determine what would be a feasible overdraft limit for that customer. We did not observe any clear trends of seasonality in our data, and as such, we selected simple exponential smoothing as our time series model. We also determined a prediction interval, which was an upper and lower limit for the customer's forecasted expenditure. Given the number of customers, we modeled the personalized limits based on two segments, low and high transaction volume, with a root mean square error of 0.87 and 1.35 respectively, indicating that the model was a suitable fit for the data. We also separated customers into segments based on their demographics to cater for individuals who may not have sufficient transaction history. So the figure here shows the prediction interval for the forecasted authorized limit for a low transaction volume customer with the following characteristics: age 31, marital status single, gender male, occupation engineering and technology. The blue line is the forecast. The purple and gray shaded areas are the 80% and 95% prediction intervals, respectively. From this plot, we can see that an authorized limit of $500 would be suitable for this customer. We segmented our customers into two groups based on their default risk. These groups were then further subdivided into two more categories based on their transaction rates. A percentage fee, which was proportional to the overdraft amount, was calculated for each of these four groups based on their default probability and their average transaction amount. The mean percentage fee for each group was set as the overdraft usage fee for that group. And the overdraft usage fee stratified structure is shown in the table here. We calculated the individual interest rate based on linear interpolation at the median of the line between the maximum cost of missed payment and the maximum cost of overdraft protection. The cost of missed payment was determined using the penalty fees a customer would incur by missing a third-party loan or credit card payment due to inadequate account balance. The linear interpolation equation is shown here, where xi and xi plus 1 are the minimum and maximum cost of missed payments respectively, and yi and yi plus 1 are the maximum and minimum cost of overdraft protection for that customer. Our personalized overdraft protection framework incorporates the option of deferred payment. Typically, overdrafts are automatically repaid once the account balance is credited. For individuals in financial difficulty, this automatic payment may cause them to overdraft again, which can be a frustrating experience and lead to customer attrition. We propose the option of deferred overdraft repayment as a means of improving customer experience. To achieve this, we modeled the time to repayment using the Kaplan-Meier estimator of the survival function, as shown here. From the survival estimates, we see that at time 31 days, approximately half the number of all customers chose to make a payment, and by 45 days, approximately 85% of customers made a payment. Based on this behavior, we can conclude that if given a choice of when to repay the overdraft limit, 50% of customers would repay on or before 31 days. Therefore, we propose a deferral period of 31 days. We compare the revenue generated from existing overdraft protection options to that of our proposed framework for 5 customers. We chose to compare the two options on the customer level rather than on a cumulative level to allow for a more granular perspective that can be scaled up to estimate the revenue generated for the entire customer base. By implementing personalized overdraft protection with interest rates and authorized limits based on customer data, the financial institution would generate a net increase in revenue of $121.50 from these 5 customers. So in conclusion, we were able to design a personalized overdraft protection framework that maintained or improved both customer welfare and bank revenue. The personalized features were based on market research and the literature related to customer opinions on overdraft protection. Additionally, the comparison of our proposed solution to an existing framework showed that financial institutions would not incur any significant losses in revenue by implementing our proposed framework. Our work on overdraft protection can be used as a starting point for fair usage policy on regulating overdraft practices. The use of customer data to personalize their banking experience can also extend to monitoring the fluctuations of customer account balance over time, which can provide insight as to which banking products and services a customer would benefit from or be likely to adopt. So thank you for listening. If you have any questions, feel free to email us at the addresses shown below. Thanks.